Hello guys, welcome back to Dear Tesla channel. So today I will discuss about static characteristics of NPN, BJT or bipolar junction transistor. So we know there is two types of extrinsic semiconductor. First type is P type and second one is N type. When we join this p-type semiconductor crystal with the n-type semiconductor crystal, then this device is called diode. Di means two, and here is two types of semiconductor crystal. So this device is called diode. And this is the junction between P and N type semiconductor, and this diode will also called PN junction diode. Now we back to the case of transistor. There is many type of transistor available in market. Example MOSFET, which is metal oxide semiconductor field effect transistor. JFET, which is junction field effect transistor. BJT, which is bipolar junction transistor. In this video, I am discuss about this BJT or bipolar junction transistor. So what is basically a BJT or bipolar junction transistor? BJT is mean bipolar junction transistor. What does mean this bipolar? The bipolar term mean that there is two types of semiconductor. One is P type and another is N type. Two types. This mean bipolar. And what is junction? In the case of MOSFET, there is another types of construction. In the case of BJT, there is a junction between P and N types of semiconductor crystal. From structural side, we can consider this is a junction. And what is transistor? The transistor means number of crystal is 3. This is bipolar junction transistor and we call it shortly BJT. We know there is two types of semiconductor crystal and number of crystal is 3. So how can arrange the transistor? The first condition is there I am used 2 P crystal and 1 N type of crystal. This is a transistor. And another arrangement is 2 N type crystal and 1 P type crystal. This is another transistor. So this transistor is called PNP transistor and this transistor is called NPN transistor. So there is two types of BJT transistor. One is PNP and another is NPN transistor. Now we discuss about structure of this two type transistor. Basically, for PNP transistor, there is two P-type crystal in two ends of this semiconductor device, and we placed one N-type crystal in between this two P-type semiconductor, and the doping is much greater in emitter and less in collector, and this is the lowest doping and opposite type of doping in base. So in a PNP transistor there is 3 legs of transistor and one is called emitter, second is called base and third is called collector. Emitter, base, collector. In the structure of NPN transistor there is also 2 N-type crystal and a P-type crystal placed between two N-type crystal, and here is emitter and here is collector, base. The doping of emitter is highest, doping of collector lower than the doping of emitter, and base doping is opposite type, lowest from collector and emitter. So let us see the symbols of these two types of transistor. One is a PNP transistor and another NPN transistor. First, PNP transistor. Firstly, I draw a circle Then this is the base. This is another two legs of transistor. If we consider this is the collector and this is emitter, a arrow is placed between base and emitter. For this is N type and this is P type, so the arrow is inwards to the base from the emitter. Now we draw the symbol of NPN transistor. This is the base. This is another two legs. If we consider this is the collector, this base, this is emitter, a arrow is placed between base and emitter. For this is a NPN transistor, the arrow is outwards to the base. In this video, we discuss about this NPN transistor static characteristics. Now we can discuss the static characteristics of NPN transistor. What is static characteristics of NPN transistor? The behavior of transistor in DC current is called static characteristics of transistor. Okay, so this is a NPN transistor. This is collector, this base, this is emitter. Now we apply a DC voltage, regulated DC voltage, which is this, across base and emitter, and we also apply another DC voltage source which is also regulated in another side of this transistor. This is VCC and this is VBB. Okay, in this circuit a current will flow which is IB. Emitter in forward biased, base also be forward biased, but collector is reverse biased. So the collector current IC flow in this direction and the emitter current is IE. IE is equals to IC plus IB. Now consider a circuit. In this circuit, this is the transistor, NPN transistor, this is base. Now I placed a ammeter which is micro ammeter in here, and we connect a battery variable power source in this terminal, and I also placed a milliammeter here, and here also a variable power source in this side. We connect a voltmeter between. We connect a voltmeter here, which is V. If we increase the voltage of this power supply, the IB is increased and also the IC will increase. And if we increase the voltage of this power supply, in the saturation region the collector current increased linearly with voltage, but when it in active region, then the collector current will be saturated and it will be a constant value. So this is the voltage is VCC and this voltage is VBB. Voltage between emitter and collector VCE. Voltage between base and emitter is VBE. Now we applying Kirchhoff's law. Here we also used a resistor which is RB. Now we applying Kirchhoff's law of voltage KVL. VBB minus IBRB minus VBE is equal to 0. It means IBRB is equals to VBB minus VBE. RB is equals to VBB minus VBE by IB. If we apply 2 volt on this terminal VBB is equals to 2 and VBE equals to 0.6 volt. So RB for IB is equals to 100 microampere. RB is equals to 2 minus 0.6 divided by 100 into 10 to the power minus 6 ohm. If we calculate it, it will give the value of 14 kilo ohm. So we can find the value of this RB. We draw the curve of VCE versus IC in different IB. The graph like this: IB1, IB2, IB3. This is the saturation region, this is active region, and for IB is equals to 0, this is cutoff region. From the graph of VCE versus IC for different IB, we can calculate the value of beta. Beta is equals to IC by IB. What is beta? In the multimeter, we can also call this HFE. What mean HFE? HFE mean also IC by IB. HFE is hybrid forward current gain in common emitter mode. And another type is HOE, which is the hybrid, which mean parameters, hybrid output impedance in common emitter mode, which is IC by VCE. So this is the multimeter and this is the HFE option. This is continuity option, which means that a circuit is continue or not. If I set this multimeter at continuity range and connect these two probe, here we can see the value 0 because this circuit is continue. This is wave generator and this is HFE, which mean hybrid forward current gain in common emitter mode. And if we put this transistor in here, then this display will show the value of current gain, and I can also calculate the value of current gain by plotting graphs, and I choose the second method. I will find the value of this transistor by plotting the graph of VCE versus IC.
So it is the graph of VCE versus IC. Here it is beta of this transistor, which is nearly 130.
So I hope all of you enjoying this video, and thanks for watching.